Hi, everybody, and welcome to our webinar on fresh features to run ClickHouse faster and cheaper on data lakes. We've got a bunch of people signed up for this, so we're going to give them 1 minute to come in, and then Alexander and I will kick things off. Okay, let's get going. I'd like to welcome you all to our September Project Antalya roadmap, where we'll be talking about fresh features to run ClickHouse faster and cheaper on data lakes. So this is kind of a snapshot of current development. We'll talk a little bit about what Project Antalya is, in fact, give you the context, and then talk about some really cool new features that have dropped in over the last couple of months. My name is Robert Hodges. I'm CEO of Altinity. I have with me together today Alexander Zaitsev, who is our CTO and is driving everything. Just a little bit about Altinity, so that in case you don't know us, I notice a number of the people on the call, you are customers. Welcome, everybody. It's great to see you. So we are Altinity. We're a vendor for ClickHouse. We started in 2017. We provide enterprise support for ClickHouse. You run it yourself any way you want, everything from telephones to massive clusters in public clouds. We support you. That's about half our customers. The other half of our customers run in Altinity.cloud, which is a managed ClickHouse solution. It can run in our accounts, or it can run in your accounts with a BYOC model. The BYOC model is very popular, pretty easy to set up, and works on 4 different clouds. So it's really everything from Amazon to Hetzner. Just a little bit of housekeeping information. First of all, we are not ClickHouse Incorporated. People sometimes get confused about that. We are actually a competitor to ClickHouse Incorporated, although, of course, since this is open source, we collaborate on many things to make ClickHouse better. Those include things like making contributions to upstream ClickHouse itself. We've done many, many, many hundreds of those over the years. We are the authors of the Altinity operator for ClickHouse, which many of you use. We work on the Altinity backup for ClickHouse, also known as ClickHouse Backup, Grafana community plugin, bunch of other ecosystem stuff that make ClickHouse systems run better. That's point one. Point two, this webinar is being recorded. So shortly after the webinar ends, you'll get a link to this recording and to the slides in PDF form, so you don't have to take frantic notes. And then finally, we have plenty of time for questions. You can pop them into the chat or the question and answer box. We'll answer them in the background. If Alexander and I are kind of tag teaming this, or we can have time at the end to discuss further issues about the features we're discussing here or anything related to ClickHouse itself. Let's go to the next slide. Okay, let's dive right in. This is a talk where we assume you are here because you love ClickHouse and you want to see it made better. So let's just start with kind of a level set. When ClickHouse was first developed, it came out with what's called shared nothing architecture, which is the way most systems for analytics were developed starting in the late 90s. And the way that it works, and if you run ClickHouse today, you know and love it. You have ClickHouse servers. They have attached block server storage off the file system. They can have multiple volumes mounted. Those servers communicate with each other over a network, and they have, in order to implement sharding and replication. When there are, because both of those involve distributed operations, you need to have some sort of record of who owns which, who are the members of the cluster, and which parts of tables do they possess, so that you can get them replicated properly. That is the job of ClickHouse Keeper, which helps manage replication as well as sending tasks across the entire cluster. Over time, ClickHouse has opened up a door to store data in S3 compatible object storage, as well as the native object storage of systems like Azure and GCP. So it started out with being able to read and write data from and to object storage, but increasingly over time, it has led to people building systems where they were pointed toward having shared data on S3 itself. That's a lot of what we're going to be talking about in this talk. So that's the basic outlines of what ClickHouse does, and this became phenomenally successful, thousands and thousands of people using it, but there's some problems. And the biggest problem that ClickHouse has today is that the data sizes for many companies, even small ones, have become enormous. So we have a customer that puts in about 20 petabytes of uncompressed data every day. That is a lot. They run hundreds and hundreds of servers to absorb this load, um, and this is putting some strains on this and other systems are putting strains on the shared nothing design of ClickHouse. Let's have a look at what they are. Next slide. Yeah, thank you. Um, so the key problem is cost. This is the thing that's really that's really very prominent. When you run these systems, of course, you want to run them as economically as possible. But if you have very large amounts of data, first of all, storage becomes very expensive if you're operating on this shared nothing model where all the tables are stored on block storage, which is then replicated, say, 2, 3, 4 times to other servers. That can be up to, sort of on the order of 10x more expensive than keeping it in S3 storage. The second problem is that ClickHouse, as I think most of you know, is a single binary that kind of does everything that's necessary to implement analytics. That means that each of those servers must handle ingesting data, so through inserts or reading from Kafka, um, merging data. That's a very prominent background activity in all ClickHouse servers. Mutating data, so applying changes if you need to change tables or drop things. And then finally, of course, because this is the whole point of it, processing select. So being able to handle the load when people start to make inquiries on the database. And because you're doing all of these things together and you can't scale them independently, or they're sort of it's difficult to do so, people tend to over provision the servers. And so you have wasted capacity. And then even with the over provisioning, you may get heavy load because, say, you're running a financial system and it's a heavy trading day. Every single analyst you have is looking at the database. You start to run out of capacity and you can't quickly scale it up. So that last problem of people coming in and hitting the systems hard lead to some knock-on issues, which are not directly related to cost, but just have to do with manageability and even stability of ClickHouse. This is a problem we want to solve. So, and that's what we're doing. So what we did was, as many of you on this call know, there is a solution that allows you to have shared object storage, which is a traditional way that you solve these problems in analytic systems. You will put the shared data on the tables on object storage, and then different groups of servers. For example, in the Snowflake model, they call them virtual data warehouses. They will come and pull the data and work on it independently from each other. So for example, you can have a virtual data warehouse that loads data, another virtual data warehouse that handles sort of quick queries for user dashboards, and then even yet another virtual data warehouse that handles long batch reports. So that model is implemented in ClickHouse Cloud, but it's not open source. So the question is, how do we offer something like this in open source ClickHouse, which most people on this call are running? And that's what Project Antalya is all about. What the conclusion that we reached after looking at this for a period of time and doing a lot of work on Parquet was to build shared object storage on Iceberg. So Iceberg is a very popular format it's called an open table format, and it allows you to define and query and update tables that live on S3 and are in most cases consist of Parquet files. Parquet is another open source format. That's the actual file format for the parts, if you will, or the files that make up the tables. That's become very prominent in the last few years as well. So if you're trying to build something in open source, it's a natural choice because Iceberg itself is open, has a very large community supporting it. The question is, how do you actually make that work as storage for ClickHouse and get the advantage of being able to, first of all, get to this cheaper storage and then also be able to scale your compute? The way that we do that is that um, we're, of course, putting in features along with the rest of the community to allow us to read and write to this, particularly read from this storage very efficiently. So, for example, being able to read Parquet quickly. But we have added a number of features. An important one is what we call a swarm cluster. These are stateless ClickHouse um, uh, servers that work together as a um, uh, uh, that work together uh, as a group, and you can basically just delegate processing of the queries on Iceberg out to the swarm, and you can have as much or as little compute as you want. This increases your bandwidth going to object storage so that you effectively can get information back more quickly. It also gives you reserves of CPU for computationally intensive uh, analytics, and equally importantly, it gives you reserves of memory. The thing that makes things fast is, of course, to have key things like the metadata of Parquet files, the metadata of Iceberg present in memory, as well as hot blocks that you're reading. And the Swarm allows you to do this. So this is a 100% open source feature. We first introduced this in the Antalya builds. This was announced in April and has been available in builds ever since then. So what we also did is we run a cloud. So our interest is aside from supplying technology that everybody can use, but our interest, of course, is to run it in our own cloud and let our users have these benefits. This is an example of what the Antalya stack looks like when it's in Antalya in our Altinity.cloud. We have users using it there, and you have the native ClickHouse clusters, so it's completely compatible. This is a branch of ClickHouse, completely compatible with what you do uh, with ClickHouse today. Existing systems is just switch to a different build, and then you can build out Swarm clusters. There are features in Altinity.cloud that let you start these things in a minute or two. And then a very important feature is we also include a built-in catalog. So Iceberg stores the metadata by default on out in storage next to the data that the metadata is describing. But that's not very efficient if you need to enumerate quickly the tables that you have and find the files in the tables. It's much simpler to put it in what's called a catalog, which is a server that gives you, for example, a REST API that you can use to query, hey, what's my list of tables? Give me the metadata for a particular table. Give me sort of an idea of what I have to do to step through the files, to actually do a query. This is handled by the catalog. That catalog is built in. So that's basically what we're doing. And at this point, I'm going to hand it over to Alexander, who's going to talk about current work, the past work that we've done, but most importantly, focus on some very recent stuff that's now available in Antalya and out there for you to use. So
thank you, Robert. Hello, everybody. Just to recap I'm going to recap a little bit what we did so far and tell you about some new features that are available as a part of Project Antalya. So we started with the query story, how to run queries in most efficient way on Iceberg and Parquet data. And this is where we introduced the Swarm execution model, which everybody can use. We introduced a number of extra caches on Parquet and Iceberg, like Parquet metadata cache, some other caches that don't always exist in upstream ClickHouse. Later on, when we launched this project publicly, we also added support for Swarm queries on Iceberg that also required some changes in ClickHouse. We worked on a cache locality because when you have a lot of nodes that serve queries from S3, you need to make sure that data, if you cache it locally, is always requested from the same node. Finally, we added IceREST catalog, and I will be talking about that today a couple of times because this is the very important and integral part of Antalya stack. What we recently did, and I will probably talk about future a bit later, but for today, we will talk about 3 new features that we added in the last couple of months. First is full support for AWS S3 table buckets. I will explain what it is, why it's so cool, why we're so excited about that, and how we implemented the support of those in Project Antalya. Then I will briefly talk about the new features in ISRS catalog for catalog management and why those are important and why it's not that easy to find it in open source. And last but not least, I will start talking about how we write data into Iceberg from ClickHouse, something which hasn't been available for a while. What are the current approaches and what are the next steps that we're going to implement? Let's start with S3 table buckets. This is a new AWS service. It has been introduced back in the end of 2024. And in a nutshell, this is a service that stores S3 as a storage, so it's object storage, and it uses Parquet as a primary data format, and at the same time, it exposes this data using Iceberg REST or Glue API. Glue is AWS specific, Iceberg REST is totally vendor independent protocol. So this is kind of an Iceberg service inside AWS. But moreover, they also added catalog management features from the very beginning. The most important feature is compaction. So imagine that you insert a lot of data into Iceberg or a data lake. And if you do it every minute, for example, if you have observability system, it may go even faster. You end up with many files. In ClickHouse, as you know, we have merges that take care about small parts and produce bigger parts. In Iceberg, Iceberg is just a catalog. It doesn't do anything. You need some service, additional service that do this management operations. And this is what catalog management features are for. Compaction is probably the most important, and this is exactly what ClickHouse merge does. It takes a number of smaller Parquet files, merges them together, resorts if needed, and produces a bigger Parquet file. And that ensures that the performance is kept on a reasonable basis. And that was a feature of S3 table buckets from the very beginning as a service. And if you look around for some other catalog implementations that you can find, there are not too many that you can take and install and deploy with such features. Usually users has to do Spark for that. Now there are S3 table buckets. There are a few others, but not too many. And by the way, Altinity is one of them. When we started to work with S3 table buckets, we immediately stumped in a number of problems. The first problem was that S3 table buckets, they required special authentication parameters that you can see in the right bottom corner. So special REST dots something that is totally specific for Iceberg, for S3 table buckets only, and ClickHouse doesn't have any way to supply such additional parameters. Of course, we could change ClickHouse, but given ClickHouse release cycle, it might take a while. So instead of changing ClickHouse in order to connect to S3 table buckets catalog, we implemented a proxy inside IceRes catalog, which is a part of Altinity Antalya stack. What IceRes catalog does, it authenticates in a correct way to AWS and then works as a proxy. So whatever ClickHouse calls to the catalog, list tables, do whatever, get the list of files for the query and so on and so forth, it is being proxied to AWS service, and the results are returned back to ClickHouse. Moreover, we discovered that the API that S3 tables is exposing, it lacks some features, so it actually doesn't implement the REST specification fully. So some commands that ClickHouse is doing, they're just not implemented by REST API. Therefore, internally, IceRes catalog doesn't use REST API. It uses different AWS API, just direct Java, that is available for Spark. And this way, we don't have any limitations of this REST API. So how it works for the user, if you have IceRes catalog deployed, you just configure it, and we have configuration examples in GitHub repository, and then you connect to it as to the normal REST catalog with the beer token for authentication or AWS parameters for authentication, and that's it. And warehouse is just a path to the bucket. Another problem that we faced when we started to work with S3 table buckets is that upstream ClickHouse just didn't work. So apparently, if you work with the regular Iceberg catalog, you have warehouse, and this is your kind of enclosure for your files. All files are relative to a warehouse base location. So when you add new files, they are kind of under this warehouse path. That's not true for S3 table buckets. As you can see in those examples, the S3 path, which is returned by S3 table buckets, is totally random. AWS services, they understand those paths very well, but it doesn't match the warehouse location in any way. And this is a limitation of ClickHouse, which still exists, and ClickHouse team doesn't address that. So in order to fix that, we made a simple fix to our Antalya builds. And if you want to work with S3 table buckets, at least for now, you have to use Altinity Antalya builds. Maybe in the future, we'll contribute it back to upstream ClickHouse. And finally, of course, we added support to Altinity Cloud. So if you're an Altinity Cloud user and if you want to use S3 table buckets, tell us. We will enable this for your environment. It could be SaaS or bring your own cloud. And once enabled, you will be able to connect to that, run some queries, and do everything that you want. A next feature. So I mentioned that some of catalog management, that S3 table buckets have catalog management features built in, and that was really cool. And of course, for our catalog that we provide as a service to the users, or users can use it because it's open source, we also implemented a bunch of catalog management features, namely 4, and those are most important ones. Number 1, manifest compaction. So when you insert multiple times in an Iceberg, every new data or every deletion generates a new manifest. In a time, you may end up with multiple manifests which are referenced from the root manifest. This is a lot of data. Of course, ClickHouse can cache it, but every time you start a cluster or every time you need to invalidate the manifest, it takes quite a lot of time. Manifest compaction is one of standard operations for catalog that some of catalogs can do, including ISRS catalog. So what it does, it collects all manifests together and merges them into one big manifest, which is much easier to read, especially from S3. As you know, every request counts, and if you make less number of requests, this is better. The next catalog management operation is data compaction. And this is totally similar to ClickHouse merge. If you have multiple Parquet files, which are small ones, and if they belong to the single partition, it makes perfect sense to merge them into a smaller amount of bigger Parquet files. This is what data compaction does, and it's currently supported as well. Finally, there are 2 operations that clean up some old data. Snapshot cleanup, it deletes old snapshots. Every time you add a new data, you generate a new snapshot. And if this new data doesn't contain some older files, those needs to be deleted, but those can be deleted only together with snapshot. So the snapshot cleanup operation, it finds the old snapshots. You can configure the age of those snapshots and deletes them by request automatically. And finally, orphan cleanup is an operation to remove unreferenced files or orphans in data warehouse directories and data and metadata. And that may appear during failures. So say you started to upload some data and you failed at the middle, or some inconsistencies in logic. If you're using a ClickHouse zero-copy replication, you probably are familiar with orphans problem. The same problem may potentially exist in any catalog implementation. And orphan cleanup, it just finds all referenced files in snapshots and deletes everything else. Those management operations can be configured and executed in two ways. You can configure them as a part of the service itself, and the service will be responsible for running those, but it has a caveat. Sometimes, for example, data compaction may be too memory intensive and CPU intensive, and since you don't need to run it too often, this may be over provisioning story. So we have another way to do it. You can run it externally using the command, and in this case you can do it on schedule, for example, using cron job, run it every hour or every day without putting extra load to catalog itself and provisioning enough resources to do the job. So this is the second feature that we put in, and the third feature which I'll be talking about is writing to Iceberg from ClickHouse. First of all, there is a partial implementation in upstream ClickHouse already in 25.7 version, which allows you to write to local Iceberg tables. So in ClickHouse, you can work with Iceberg in two ways. You can work with catalog, and this is what we're doing, or you can work directly with the data in some bucket, interacting with data and metadata file directly without any catalog. This is, of course, not preferable because you don't have any concurrency control and so on and so forth. And you can only work with a single table this way. You can't work with the database, but this is something that ClickHouse supports. And for this and only this use case, ClickHouse team has implemented writing support. So it doesn't use any catalog. It only can update metadata, but this is the beginning. Maybe in a few months they will add better support, but for now, all issues mentioning the missing writing to Iceberg are closed for some reason. So we need a different approach to that, and we do have it. We have ICE, and I will show you two ways how you can use ICE in order to write data from ClickHouse to Iceberg. First is very straightforward. You insert data from ClickHouse. In this case, I inserted even from S3 bucket, but it could be MergeTree table as well, to the special location inside your catalog warehouse. So if you use Iceberg catalog, then inside the catalog you have structure, which is very, very logical. You have namespace as a part of the path. It was public blockchain in this particular example. You have BTC, which is a table name, and then you have data and metadata directories. If you have partitioning, there could be some additions to the paths. So what I do here, I insert data directly into data directory. So the data from ClickHouse goes directly to the data directory inside the catalog, and then I just need to run the ICE command locally in order to register this data into the catalog, into the snapshot. I even don't need to copy. You see the no copy flag. It allows us to skip double copy. But if this data is somewhere else, not in the catalog warehouse, but somewhere else, I can remove this no copy flag, and in this case, ICE will copy data over the network and put in the catalog location. We have plenty of examples how to use ICE, so welcome to check our GitHub project. Of course, this is not very convenient because you have to run two commands, one command in ClickHouse and one command externally. So we thought about the way to automate it. And we implemented a special mode for ICE, which is called watch mode. In this watch mode, what is happening is the following. You can, not you, but we can set up the special SKS service. And this is a part of AWS, of course. And it's very straightforward. You can do it with Terraform. You can do it with other ways, which will detect events on the specific S3 bucket. And ICE can listen to those events, and this event could be like the new file appeared, can listen to those events and automatically commit new files to the catalog. So instead of running ICE on every single insert, you run it in the watch mode, which is just hanging and waiting for events to come. And as soon as new data appears in the location, it is automatically committed to the snapshot and to the catalog. From the user perspective, from the ClickHouse user perspective, the user just inserts data in a certain location, and it will automatically appear as a part of Iceberg table. So no other actions are needed. In Altinity Cloud, we of course automated that, so you don't need to run ICE command directly. It is running in the background if you specify the special flag and which tables to wait. We have examples in GitHub repository. Check it out. They are ready to run. They're Terraform, very, very simple Terraform scripts. You can run them and check how it works. This is not ideal still. If you try to run this for the bigger amount of data, and in this example, I tried to run it for full month of data with automatic partitioning using partition by expression for a three table function, then it can blow up of RAM because ClickHouse is not very efficient in memory management when writing to Parquet. Also, there are some interesting limitations that we bumped into. For example, the Parquet supports different data types compared to Iceberg. So for example, in Parquet, you may have a nanoseconds time precision, but in Iceberg you cannot. So in order to write such Parquet files into Iceberg, you will have to do type conversion. So this is what I'm doing in this example, converting timestamps to microsecond precision, but originally it was in nanosecond. And finally, ClickHouse has at least two different ways to write Parquet files. It originally was using Arrow library for reading and writing. Later on, somebody added the native writer, which is sometimes called native, sometimes is called custom. And apparently this custom writer is not fully compatible with Parquet spec. We have discovered that for reads it's great, but for writes, sometimes you may want to disable that. This is something that we will fix in the future. By the way, ClickHouse team or some external contributors, they are adding a new version of a Parquet reader, native Parquet reader, which is claimed to be 3 times faster than existing ones. So this is a huge improvement. So next step, how are we going to fix this problem with the memory and with writes and make it more user-friendly? As we speak, we are working on a new extension to ClickHouse, which is called Alter Table Expert. And this Alter Table Expert will allow users to write parts or partitions directly to S3 storage or later to Iceberg. And why it's better than select, of course, because, for example, we don't need to do resorting or any kind of sorting. So we move data from MergeTree to Parquet, preserving the same ordering, preserving everything that MergeTree does. Also, we take care about atomicity. So if you run this command, then it either fails or succeeds. For this exactly reason, it's retriable. If you restart the server, and then we expect that export will finish after server is back online. And finally, it is going to be memory efficient. So we don't want the server to blow up when somebody exports partition to S3, of course. So this is what we're currently working on, and it should be available in a few weeks, maybe in October. Comparing to what upstream has versus Antalya, because a lot of people are curious. Some features are available both in upstream ClickHouse and the Antalya version of ClickHouse. Some features are not. The reasons are different for that. So, for example, catalogs, of course, available in here and there. Swarm discovery, this is just an extension to standard ClickHouse functionality, and we were able to push it to upstream pretty easily. But some other features like Swarm queries, for example, we couldn't commit to upstream because it kind of violates their view on ClickHouse and maybe violates with some functionality that they are working on, conflicts with some functionality, so they just don't accept that. S3 table buckets, we actually haven't tried to push anything to upstream yet, but as far as I can see, they are moving in a bit different direction. They don't understand that this file location shouldn't be hard-coded to the warehouse, and this is a big problem. So having said that, we are trying to push as much of our work to upstream, but it usually comes after we deliver it in Antalya builds. Getting back to roadmap, so that are just 9 maybe major steps, and some of them have already passed. We discussed it at the beginning. What is coming in the next few months is the following. We are now hardly working on the new Altinity Antalya release based on 25.6 upstream ClickHouse. The previous Altinity Antalya was based on 25.3 with some backports from newer versions. This time it's pretty much the same. It's 25.6 base version with some backports from the newer versions. And of course, all Altinity Antalya features are there. And this release is coming in September. The most important things that we expect in this release is much better support for glue, for AWS glue, as well as support for joins in Swarm queries and some other features. Later, by the end of maybe it's already going to Q4, we will release the writing to Iceberg tables. We think it will be a part of 25.8 Antalya build, so it's going to be in October. So it's already Q4. I showed you some ways to write to Iceberg, and this export partition is a very important step that we are going to release pretty soon. Later this year, we plan to release support for what we call infinity tables, and this is the seamless extension of MergeTree or replicated MergeTree to Iceberg. When, from the user perspective, a user just runs queries on a table, and ClickHouse automatically decides that part of the data should be retrieved from MergeTree, and the part of the data should be retrieved from Iceberg, depending on some watermark conditions. We're actively working on developing this feature right now.
Hey, Sasha,
Yep.
if I could jump in, I actually updated your slides and put a picture of the Infinity table implementation right after this one. If you refresh, you'll be able to see it and walk people through the parts we have. You'll need to
Okay,
yep.
okay.
Yeah, exactly. So
Yeah,
it's just
uh-huh.
for,
Let me finish on AWS Swarms. So we discussed the query swarms that help you to scale query performance as you need. But the similar problem may appear on a jest when you have a lot of data coming into ClickHouse. It at least the big part of the processing is stateless, like data parsing, producing Parquet files or producing MergeTree parts, etc. And we plan to offload this stateless processing part into what we call ingest swarms. So, for example, ingest swarm can read from Kafka, right? It can have a Kafka engine and materialized views for processing, but at the end, it will produce MergeTree parts or Iceberg files. And that will allow you to scale ingest independently from your query. So if you have a bigger incoming traffic, you just add more nodes to your NG swarm without affecting your main system, which is used for analytics. So now about infinity tables, this is a design that we're working on. So as I said, from the user perspective, it's just a table, but underneath, this is an infinity table, which is smart enough to route queries to the MergeTree or to the Iceberg or even to the Swarm, right? If you have a lot of data and you need Swarm to process it. So this is all it's kind of similar to merge, not MergeTree, but merge table in ClickHouse and distributed table in ClickHouse at some extent. So we're kind of blending them together to make this infinity table. So that's all on technical part. Some extra housekeeping here. We have a lot of resources on Altinity Antalya, both on altinity.com documentation site and also on GitHub. Check out the project, and if you have any questions, come and ask us on Slack. If you're Altinity user already, you have a channel with us. If you are not Altinity user, you can use our public Slack workspace. To summarize what we just talked today, the Project Antalya is our view on how to make ClickHouse better and how to extend its capabilities to use Iceberg as a stable storage. At some extent, it's alternative to what our friends from ClickHouse Inc. are doing with shared MergeTree, but it is even bigger because it allows this data to be retrieved from other systems, not just ClickHouse. The important part of the Project Antalya is Swarm clusters. So far, we have Swarm cluster for queries, but we will extend it for writes next year as well. We did a lot of work on caches. They are vital for performance when you work with object storage, and we will continue to work on that. If you have any ideas and suggestions how we can cache things better, we will be happy to hear. Since Swarm is stateless, we can use spot instances. We haven't discussed it today, but this is a real cost saver. So for swarms in AWS and maybe in GCP as well, it is really cost saver if you use spots. There is a risk that spot disappears during query execution, but if your query runs more than 30 seconds, maybe this is you need more resources anyways. It's not very fast. We were talking about ICE and ICE REST catalog and what extra capabilities it can give. When we started Antalya, we were not thinking about implementing our own catalog. We were looking for something to adopt, but we couldn't find anything. Lakekeeper, which is a catalog on Rust, comes close enough, but we need more control in order to implement our vision. That's why we implemented our own catalog, and we keep developing that. It's open source, so feel free to contribute. And finally, it's all managed in Altinity Cloud. What coming next, and maybe in 3 months from now, we'll be ready to talk about on the next webinar, is production-ready writes to Iceberg. I have demonstrated some tricks to you today, but by the end of the year, we plan to do this export partition production-ready. Also, infinity tables are coming. We are also aiming to finish it by the end of this year, at least as a MVP solution. And finally, NG Swarms is the last piece of architecture that we have in mind. We haven't started to work on that yet, but we plan to start in a couple of months in order to deliver a solution in Q1 2026. That's it, and I think we are happy to answer any questions.
Sasha, thank you. Before we turn to questions, I want to just highlight the fact we're doing a number of meetups, in-person meetups on what on the topic of real-time data lakes. So all these things that we've been talking about today, these are going to include, they're put on by Altinity, but also we're sharing this with Snowflake, Stellar Data. Those are the folks who do Star Rocks. The Amazon team will be there to talk about S3 table buckets. And so the first of these meetups is on October 2nd in New York City. We're also going to do one in London. I know there's at least one person on the call that we're probably going to meet there because we're doing it in their tentatively doing it in their offices in the city, followed by Atlanta and San Francisco. So we'd love to have the chance to meet with you and talk about this. A big thing is this is completely open source. We we want people to join us, contribute to this, try it out. It's it works. We've been involved in open source for a really long time, and if you can get a group of people that solving these problems together, some of our collaborators include Sentry, Posthog, and others. You can do some amazing things. So please join us and check it out and help us build it. So Sasha, there's a couple of questions answered in background that I think you might want to look over from Jeff. They're about the Delta kernel. And this is really interesting because he's bringing up some issues that we thought about early on. First of all, why do we choose Delta? And then just trade-offs between our catalog and Polaris and Unity, which are things that you kind of touched on, but I think are worth going over.
So we were considering Delta at the beginning, but we saw that Iceberg gets more and more traction, especially after Databricks acquired Tabular. And that was for us an indication that we better to invest more in Iceberg support. And that was probably right. As you can see, AWS table buckets, S3 table buckets, they are also Iceberg compatible, but not Delta compatible. So that's why for us right now, the primary catalog implementation is Iceberg. But of course, ClickHouse can work with Unity, it can work with Delta, and I have seen a lot of improvements from ClickHouse core team to Delta support. Maybe they have customers who are pushing them to for that. The Swarm functionality and Antalya features, they are more or less catalog agnostic. Of course, we have more caching for Iceberg, but the basic Parquet reading and writing functionality, it is catalog agnostic. And we have caches on Parquet level, like metadata cache. We have some logic inside ClickHouse query engine to work with that efficiently. So if you use other catalog, that shouldn't be a problem. But if you face any performance issues, we'll be happy to look together and see if we can solve them.
And I think there were, if I could add a couple more things on the catalogs, one of the things that was in it, we talked to a huge number of people about this topic. And one interesting finding in talking to people is that a lot of people are thinking about data lakes. A lot fewer people have actually implemented them. And so first of all, we wanted something that for people who hadn't made a choice about catalog or by, hadn't, still really thinking it through, that we would have a catalog that would just pop up and run anywhere. Obviously in our cloud, because we need something simple and highly manageable to run there that's portable across a bunch of different environments. But also people are running this, many of our customers are self-managed. And in fact, the wider user community has a huge number. There are much more people managing ClickHouse themselves than actually running in clouds at this point. So that was thing, have something very, very simple that you could use. The other point about catalogs is that ClickHouse, as Alexander has stressed, is adding, increasingly good support for other types of catalogs. The one that we're focused on right now is OsGlue, and our next build will have fixes for that. That's the most popular one that we hear of from our customers. Obviously, Unity and Unity and Polaris are also important. And then Lakekeeper, as Alexander mentioned, is an interesting new one. We'll be looking at that. We know the folks that are working on that, and in fact, they're coming on our podcast on Friday. uh, we'll definitely be checking that out as well. So we're pretty agnostic about, everybody's going to make different choices on this. Uh, our catalog is mostly just for ease of use, and it is completely, it's just a wrapper on top of the Java library. So its behavior is very consistent with the open source Java libraries that exist today.
Thank you,
Um,
Robert.
yeah.
Omar has a very good question about the Ice Watch. So Ice Watch can watch any bucket, but in order to set up this watch, we need some control about cloud infrastructure or help of the external infra team to set it up. So in particular, you need to set up these watch events to be delivered to SQS. This is number one. And number two, the catalog should have enough credentials or authority to load data uh, from, from this external location. Or if you don't want to load data or want to keep it in this external location with no copy, then the catalog should have enough credentials to read it. Otherwise, you cannot read it from ClickHouse. Question from Alexander Gedranovich about GCP Big Lake Metastore. We have a customer who is asking us to look into that, but this is for Q4. Right now, we don't have any evidence that it works or it doesn't work. So if you have some free time to test it out, we will be actually very thankful for you. But from our side, we will turn to GCP Metastore later this year.
Yeah, I think, Alexander, you mentioned the path issue that we've looked at. Another kind of interesting area where, because ClickHouse, the original implementation of Iceberg tables made some pretty strong assumptions about where paths were located. Another interesting area that we see people pushing on is they actually have, there's actually cases where the metadata is stored in object storage and the files are stored on a distributed file system. This is like in an HPC environment. So that's another use case that's pretty narrow, um, but it's used by some really big people in financial services. That's how they manage data. And they're not necessarily putting it on object storage. It's in their HPC environments in what amount to on-prem data centers. So there's all kinds of interesting variations on this. Uh, our, our goal is to, and I think for folks working on ClickHouse is to make them all just work through ClickHouse so that your applications connect. You get a single view of data no matter where it's located. That's basically what we spend. What we're basically thinking about that literally every day. So if you have different use cases and that involve adapting storage in creative ways, we'd love to hear from you. This is where I think some of the key innovations are coming around data lakes. I think Alexander, do you see any other questions? I see the two that you got.
No,
Um,
I don't see
yeah,
anything else.
yeah,
Let me check.
don't see in chat.
Yeah, maybe that's it.
Yeah, well, oh, here we go. Let's see, the Infinity tables position ClickHouse to be able to have hot reads for newly arriving tables. Oh, thank you, Omar, $20. I'd throw you a t-shirt if this was for cases where, as mentioned in my previous game, you have external compute inserting into Iceberg or compute agnostic access to data. Um, is there any appetite to pre-cache metadata and perhaps take it a step further optionally cache recent data similar to the hot table part of the infinity table goal? Okay, let me say what I think I saw here, which is that you have external compute pushing into Iceberg, and you would actually like to see that data, that Iceberg data, as quickly as possible. Um, yes, we have been thinking about this. This was something that was one of our close design partners is a does a lot is a high frequency trader, and they have exactly this problem, and we see this elsewhere. So there's a couple of ways that we're thinking of attacking this. One uh, is actually to have introduce something sort of a follow-on to the ingest clusters, is to have ClickHouse actually do what's called a Lambda architecture, where there's two paths going in. One goes into the hot data, goes into MergeTree, just as Alexander was showing you. But in fact, there would be a separate ingest path or path from ingest where we would stuff it into Iceberg as quickly as possible. So that allows you to get, and I'll give you an example of why you want to do this. There are tools that want to see data in um, in Iceberg, like Looker, for example, which has really good Iceberg support. You can query it through Trino. You can't query Looker can't query data through Iceberg very well. So basically, if we can jam the data in there as quickly as possible, that enables you to have two views of the data, and then the infinity tables uh, can decide which one to use based on your query. And the other thing, there's sort of some science fiction ideas of having, ingest clusters which also cache the data and make it, have hot data even in memory. Those are more science fiction. I think it's going to take us a while to get to those. I think, hey, here's a really good example from Tin. I have a table using aggregation functions. Have a look at this one, Alexander. This is a really interesting question. How to do aggregates. Oh, did we lose? Okay, I think we may have lost Alexander. So I'll answer Tin's question and then we'll probably close it up. Um, yeah, so the thing with Tin, if I understand your question correctly, you're looking for basically putting sort of partially aggregated results inside an Iceberg table. You're absolutely right. There isn't a way to do that. And in fact, we think in the short to medium term, the way to do this will be to keep your source data in Iceberg, but to keep the materialized views in ClickHouse. And we will be adding features that allow you to feed materialized views from Iceberg. You can subscribe to changes in Iceberg, and you can use that to populate materialized views. Okay, we're at the top of the hour, so I think we're going to call it a day. I'd like to thank everyone for contributing and for listening to this and the great questions. Please do contact us. You can come to altinity.com, join our Slack. We're all available. We're also available on LinkedIn, and we'd love to hear from you. And of course, for those of you who are customers, send us the questions through support tickets, and we will work with you to make this stuff work. So thank you, everybody, and have a wonderful day.